We present IMU-Aided Event-based Stereo Visual Odometry. In this paper, we improve our previous work Event-based Stereo Visual Odometry in 3 aspects, including mapping completeness, tracking accuracy, and computational efficiency. We build our system on top of ESVO, and in order to overcome its limitations, we make improvements to each of the 3 modules. Our framework additionally introduces 3 modules, namely the efficient edge pixel sampling strategy, the temporal stereo mapping operation, and the usage of gyroscope measurements. We propose a method called adaptive accumulation that can control the amount of events to be accumulated according to the local event dynamics. For each block area, the accumulation terminates once the contrast reaches a certain threshold. Our method preserves relatively complete edges with the least redundant points while keeping a high signal-to-noise ratio. The proposed temporal stereo method imitates ESVO's mapping strategy in the sense of applying a temporal block matching plus a one-step nonlinear refinement. To fuse multiple temporal stereo estimates, we investigate the probabilistic characteristics of the temporal stereo results. As shown in this figure, both the temporal stereo residuals evaluated on adaptive accumulations and the static stereo residuals evaluated on time surfaces approximately obey a student's t-distribution. Given the local map, the most recent time surface, and also the initial orientation from IMU pre-integration, the tracking module calculates the camera pose. The gyroscope's measurements can help to overcome the insensitivity to the yaw component in the general 6 degree of freedom motion estimation via a 3D to 2D spatiotemporal registration process. We compare our mapping results against those of the original ESVO pipeline. Our results achieve better performance in terms of reconstruction completeness and local depth smoothness. In the results of ESVO, we observe that the horizontal structures are either missing or estimated inaccurately due to the aperture problem. This issue is resolved through the proposed temporal stereo operation and a further depth merging process in our work. In the evaluation of tracking, our trajectories are more consistent with the ground truth compared to those of ESVO. Besides, our framework scales better with event streaming rate featured by modern event cameras with a high spatial resolution, indicating a step forward of direct methods for practical applications.